Ever heard about that massive blackout that hit Quebec back in '89?
Yeah, I vaguely remember hearing about it.
Well, it wasn't some regular power grid failure.
Oh, really?
It was a solar storm,
Wow.
a direct hit from space weather.
Ah.
And as we rely more and more on technology,
Right.
these events could cause even more chaos than just a blackout.
I could see that.
So today, we're diving into NASA's Tracers mission.
Okay.
It's trying to help us stay ahead of the curve
Mhm.
when it comes to these invisible threats from the sun.
Makes sense.
We've got a bunch of articles and press releases,
Yep.
and luckily I've got an expert here to help break it all down.
Well, what's so interesting about this is we're not just talking about some far-off cosmic phenomenon.
Right.
This magnetic reconnection,
Yeah.
the
Right.
process driving these solar storms, it's happening all over the universe.
Okay, wait, hold on. What exactly is magnetic reconnection? I get that it causes these solar storms, but how does it actually work?
So think of it like this. You've got these magnetic fields,
Mhm.
invisible lines of force. They're constantly moving, bumping into each other.
Okay.
And when they collide in just the right way, they snap and reconnect, releasing a ton of energy,
Oh, wow.
like snapping a rubber band.
Okay.
But instead of a little twinge, you get this blast of charged particles
Right.
hurtling towards Earth at crazy speeds.
So it's like a cosmic rubber band snapping.
Yeah, something like that.
Okay, that's a pretty vivid image. I can
know.
imagine that. And those particles are what can cause blackouts, like the one in Quebec.
Exactly. And it's not just blackouts. They can mess with satellites
Oh, right.
and even be dangerous to astronauts up there.
Yeah, that makes sense. So it's not just about keeping the lights on. We're talking about communication networks, GPS, even like financial transactions, all that stuff.
It's a big deal.
Yeah, that's a real world impact for sure. So how does this Tracers mission, how does it fit into all of this?
Well, TRACER stands for Tandem Reconnection and Cusp Electrodynamics Reconnaissance Satellites.
Yep.
Bit of a mouthful. But basically, it's two identical satellites
Okay.
set to launch in 2025
Okay.
that are going to give us a much closer look at magnetic reconnection.
2 satellites. Why 2?
Well, they're going to fly in tandem
Okay.
through these areas called the polar cusps. Think of them as funnel-shaped openings in Earth's magnetic field, right over the North and South poles.
Okay, so funnels in our magnetic field. Got it. Why there?
Because those are the best spots for observing magnetic reconnection. It's where the solar wind, that constant stream of particles from the sun, slams into Earth's magnetic field.
So it's like setting up camp, right where all the action is happening. But how do 2 satellites help?
Having 2 satellites
Yeah.
flying one behind the other allows scientists to compare the data and get a 3D view
Okay.
of this invisible process.
Got it.
They can see how the reconnection changes over time, how it evolves.
Right.
It's like having 2 eyes in space.
That makes sense.
Which is crucial because, well, we're dealing with something we can't even see directly.
So they're getting a front row seat to this cosmic energy show, but they're also getting a depth of information we wouldn't get with just one satellite. This sounds like some pretty complex tech.
It is the polar cusps,
Yeah.
where tracers will be focusing. They aren't just static funnels, they're incredibly dynamic regions
Right.
where the magnetic field lines converge. And to capture all of that, Tracers is using a suite of sophisticated instruments, including a plasma wave instrument and a magnetometer.
Okay, break that down for me. What do those instruments actually do?
So the plasma wave instrument, it will be listening to the music of space, so to speak.
Oh.
It can detect these radio waves generated by the particles as they zip around during reconnection.
So it's kind of like eavesdropping on the particles.
Yeah, you could say that.
That's pretty cool. What about the magnetometer?
That one's measuring the strength and direction of the magnetic field itself,
Okay.
like having a compass in space. But instead of pointing north, it's tracking those invisible twists and turns of the magnetic field during these reconnection events.
That's got to be a lot of data to process. But, what's the big picture? What are scientists hoping to learn from all of this?
Well, one of the biggest goals is to figure out how to predict space weather more accurately.
Okay. That sounds like a pretty tall order. Is it even possible to predict these solar storms? They seem kind of random.
There's definitely some randomness, but there are also patterns and triggers. Right now, we're a bit like meteorologists, trying to predict a hurricane with only a windsock.
Oh, okay.
Tracers, by gathering data from inside the reconnection zone, could help us build much more sophisticated models,
Okay.
giving us a clearer picture of when and where these solar storms might erupt.
So instead of being caught off guard we could actually get some warning.
Exact.
That would be a game changer for sure.
Imagine getting an alert on your phone saying, solar storm incoming, power outages likely in 24 hours.
Wow.
We could take steps to protect our infrastructure.
Reroute flights, maybe even schedule surgeries for a different day.
Wow, a solar storm forecast. Right on our phones. I like where this is going. So how are things looking for tracers? Is this mission on track?
They've actually hit some major milestones recently.
Great.
The 2 spacecraft were completed back in October.
Oh, wow.
And are currently undergoing final testing and integration.
Okay.
Soon they'll be shipped off to Vandenberg Space Force Base in California to get prepped for launch.
Sounds like things are moving along smoothly. Did you see that picture of one of the tracer satellites in the clean room?
I did, yeah.
It looks like something straight out of a sci-fi movie.
Yeah, it's pretty impressive. David Miles, the mission's principal investigator, he's been pretty vocal about the team's progress and excitement.
Cool.
He's particularly enthusiastic about how tracers will revolutionize our understanding of space weather.
Well, he has every right to be excited.
Yeah.
Especially since the tracers team passed a critical review back in August.
Yeah.
They're officially moving into Phase D of the mission now. That's right. Phase D is all about moving from development to delivery, assembly, and launch preparation.
Okay.
They're in the final stretch before those satellites blast off.
And this isn't just a NASA solo act, right? It's a team effort.
Absolutely. It's a collaboration between NASA, the University of Iowa, and the Southwest Research Institute.
Wow, that's a lot of people.
They're bringing together expertise in spacecraft engineering, space physics, and data analysis. It really shows the power of collaboration in scientific discovery.
It's like the Avengers of space weather research. You've got the brains, the tech, and the willpower to solve this thing. But tell me, besides being able to predict these solar storms, the obvious benefits, what else are scientists hoping to learn from tracers?
One of the big mysteries is what actually triggers magnetic reconnection in the first place.
Oh, interesting.
It's not like these magnetic fields are just constantly colliding and exploding all the time.
Right.
There's a trigger, a tipping point, and we need to understand what sets it off.
So it's like figuring out what lights the fuse on this cosmic fireworks show.
Yeah, pretty much.
Okay, that sounds like a pretty fundamental question.
It is. And understanding that trigger is essential for accurate space weather prediction.
I can see that.
Right now, we're pretty good at observing the effects of magnetic reconnection, but we're not so good at predicting when and where it will happen.
So tracers is going to help us move from hindsight to foresight.
Exactly.
Really? That's pretty remarkable.
There's also another big question they're hoping to address: how the energy released during reconnection gets distributed.
Okay.
It's not just about the initial blast. It's about understanding the ripple effects, how that energy spreads throughout Earth's magnetosphere and impacts our atmosphere.
So it's like tracking the shock waves from an earthquake, but on a cosmic scale.
Exactly. Tracers, with its 2 satellites flying through the reconnection zone, will give us an unprecedented look at this whole chain reaction, from the initial trigger to the far-reaching consequences.
We've come a long way from just looking up at the northern lights and wondering what caused them, huh?
We have.
Now we're sending these sophisticated satellites to actually dissect the very process that creates them.
It's pretty amazing.
It really is. It's a real testament to human curiosity and our drive to understand the universe, you know?
I agree.
And this understanding, as we've been discussing, has very real benefits for our society. It's like we're finally starting to connect the dots between these seemingly distant cosmic events and our everyday lives. Speaking of connections, there's something that's been on my mind.
Oh, that's that.
We've been talking about how this mission is going to change how we understand space weather. But you said earlier that magnetic reconnection happens all over the universe. Does that mean the data from tracers could be useful to astronomers studying distant stars and galaxies too?
That's a great question. And the answer is yes. While tracers is focused on studying magnetic reconnection near Earth, the insights we gain could absolutely be applicable to other astrophysical environments.
That's fascinating. So by studying this phenomenon right here in our own cosmic backyard, we're actually gaining insights into processes that are happening billions of light years away.
It's like having a miniature laboratory.
Yeah.
Right here, to study something that's happening on a universal scale.
Wow.
And who knows, maybe the data from tracers will help us unravel other cosmic mysteries, like how stars form or how black holes behave.
Whoa, that's pretty mind-blowing. It makes you realize how interconnected everything is. From the smallest particles To the largest structures in the universe.
It really does. And it highlights why it's so important to invest in scientific research, even if it seems far removed from our daily lives.
Yeah.
You never know what kind of breakthroughs might come from exploring the unknown.
Well said. And speaking of breakthroughs, the fact that the Tracer's mission is moving into Phase D is a huge step forward. It's like the countdown has officially begun.
It has. And when those satellites launch in 2025, we'll be one step closer to understanding, and maybe even predicting, those invisible forces that can cause so much chaos down here.
Okay, before we get too excited, what stands out to you as the most exciting part of this Tracer's mission? What are you most curious about?
What really gets me is the potential for totally unexpected discoveries. Every time we explore space more deeply, we encounter something new and amazing.
Right.
Tracer is designed to answer specific questions. About magnetic reconnection, sure, but who knows what other secrets it might uncover along the way.
It's like we're sending this high-tech fishing expedition into space.
Yeah.
We're casting our line for magnetic reconnection, but we might reel in something we never even expected. That's what makes space exploration so thrilling. You never know what you're going to find.
Exactly. And that sense of wonder and discovery is what keeps us exploring, pushing the limits of what we know.
Well said. And on that note, let's shift gears a bit.
Okay. Yeah, let's kind of shift gears a bit and dive into a different but related aspect of the Tracer's mission.
All right, I'm listening. What you got?
Well, we've talked a lot about the practical stuff, like understanding and predicting space weather. But there's another side to this mission, something that speaks to our fundamental human curiosity.
Oh, you mean like the wow factor of exploring the universe?
Exactly. We're sending these sophisticated instruments up to study this invisible, incredibly powerful force of nature.
Right.
It's like we're peeking behind the curtain of reality, trying to understand how the cosmos works.
Yeah, I get that. Like when we were kids looking up at the stars and wondering what's out there, that never really goes away, does it?
It shouldn't. And Tracers reminds us that there's still so much we don't know. Every time we send something up there, a probe, a telescope, a satellite, we come back with more questions than answers.
That's so true. Remember that time we covered that mystery of those fast radio bursts coming from deep space? We were close to an explanation, and then, bam, new data changed everything.
Exactly. It's that back and forth between what we know and what we don't know that keeps science going. And Tracers is right on the edge of all that.
It's funny, we think of space as this vast emptiness, just a backdrop to our little planet. But missions like Tracers, they show us that space is anything but empty. It's full of invisible forces that are constantly messing with our planet and shaping our lives in ways we're only beginning to figure out.
It really makes you think, doesn't it?
It does.
That we're just a small part of something much bigger and more complicated than we can imagine. And that being here on Earth is connected to all these cosmic processes.
It makes you wonder what other connections are out there, what other mysteries are hidden in space, just waiting for us to find them.
That's what's so cool about science. It's a never-ending journey of exploration and discovery. And with missions like Tracers leading the way, who knows what we'll find in the years to come.
So as we wrap things up, I want to leave our listeners with something to think about. We've talked about the science goals of Tracers, the possibility of predicting space weather, protecting our technology, all that, and even how it connects to what's happening across the universe. But there's something deeper here, something about our place in the cosmos.
I'm curious to hear your thoughts.
You know how people say, we are stardust?
Yeah.
Because the stuff that makes us was made in the hearts of stars. Well, missions like Tracers, they take that idea a step further. It's not just about the building blocks of life, it's about the forces that shape us, the cosmic dance of energy and matter that connects us to the farthest reaches of space and time.
That's a beautiful way to put it. It really emphasizes how everything in the universe is connected.
It is, and it makes me wonder how we define our place in all of this. Are we just along for the ride, or do we play a bigger role, like explorers, caretakers, maybe even translators of this grand symphony of the universe?
That's a question we all have to think about. But one thing's for sure. Missions like Tracers give us the tools to understand this web of cosmic connections better, the connections that tie us all together.
They do. And the more we learn about the universe, the more we learn about ourselves, too. So before we go, here's a challenge for our listeners. Don't just look up at the stars with wonder. Look up with a sense of connection, knowing you're a part of something much bigger than you can imagine. Because we really are children of the cosmos, shaped by the same forces that light up distant galaxies and create the auroras we see in our own sky. Thanks for joining us on this deep dive, and until next time, keep looking up and keep thinking about your place in the universe.
Yeah, it is a good reminder. Exploring space isn't just about data. It's about understanding where we fit in the grand scheme of things.
It really is. And it's funny how we've come full circle. We started talking about practical things, like blackouts, satellites going haywire, even the economic impacts of space weather.
Right.
But we ended up thinking about our cosmic origins and how we're connected to this vast universe.
It just goes to show, science isn't just cold facts. It's about wonder, pushing boundaries, and tackling those big questions that humans have always been fascinated by.
Exactly. And tracers, with its focus on magnetic reconnection, is a perfect example of how science can bridge that gap between the practical and the, profound.
I agree. On the one hand, we're talking about keeping the lights on and making sure astronauts are safe.
Right.
But on the other hand, we're trying to understand these forces that shape the entire universe. The same forces that created stars and planets, including our own.
It's like we're zooming in and out at the same time. We're looking at the tiny details of magnetic reconnection, but we're also seeing the bigger picture, how it all connects to the universe.
And that change in perspective, that's what makes this mission so exciting. It's not just about data. It's about expanding our awareness, understanding where we fit in.
So, as we wrap up this deep dive into the Tracers mission, I want to leave our listeners with one last thing to think about. We've talked about the science, the tech, the benefits, even the philosophical stuff. But it all comes down to this. The universe is full of mysteries, and we humans, we just have to figure them out.
It's what makes us different, right? Our curiosity, our need to explore, to understand, to connect the dots, and make sense of everything around us.
Absolutely. And missions like Tracers, they prove that. They show that we're not just sitting here on this planet, we're active participants in the grand cosmic show.
And who knows what amazing discoveries are waiting for us as we keep pushing the boundaries of knowledge and exploring the unknown reaches of space.
Well said. And on that note, we'll leave you to think about those cosmic mysteries and the incredible journey of discovery ahead. Thanks for joining us on this deep dive into the Tracers mission. And until next time, keep looking up and keep exploring.